Here we will sketch the graph of the function 1/2 times 3x minus 1 for x less than or equal to 3, and we'll use that graph to find the absolute and local minimum and maximum values of the function. So we have f of x equal 1/2 times 3x minus 1, and x belongs to the interval negative infinity up to 3, including 3. So we know this is a line. For that, we need to draw the line. We only need 2 points. In particular, at the right point of the interval, 3, the value of the function is f at 3 is 1/2 times 3 times 3 minus 1 is 1/2 times 9 minus 1 is 8 over 2 equal 4. So f at 3 equal 4. That's a result we are interested in because this is the right point of the interval. So we use that value to draw the line. So we put the value here. This point is the image of 3 is 4 here. And then we need another point, for example 1, when x equal 1, f at 1 is 1/2 times 3 times 1 minus 1. And that is 1 because inside parentheses we got 3 minus 1 is 2 over 2 is 1. So at 1 we have image 1 as we see here. And with that we have completely defined the graph of the function. And there is an increasing behavior of the function, but if we go to the left, function is always descending this way. So this is it. This is the graph, and from the graph we see easily that we have effectively and highest point in the graph, which is the image at 3, which is 4. So f has an absolute maximum value 4, which we calculated here, and that value occurs at x equal 3, which is the right point of the interval of the domain here. Okay, but that's all there is to it because there is no local maximum, because if we take any point on the graph, there is always points or numbers with images larger and smaller than the image of the point. In particular, the right point of the interval, that is this point here, is not a local maximum because we have no graph to the right. Even though the function could be defined there, we have taken this domain, so we have no local maximum at the right point and at no other point. So there is no local maximum. And in regard to the absolute minimum, there is no absolute minimum at all for this function in this domain because the function is always increasing. That is, if we move to the left, this direction here, this graph is always descending. So there is no lower bound to the graph of the function. So f has no absolute minimum, but there is also no local minimum because at any point there are images larger and smaller than the image of the point. So no absolute or local minimum. So this is the result. The only element we found is an absolute maximum of the function with value 4, and that occurs at the right point of the interval x equals 3. And that's all for this function.